Imagine watching the universe bend in real time. Not metaphorically, literally bend. Two supermassive black holes, each billions of times the mass of the sun, are spiraling toward each other right now. Space itself is beginning to vibrate. This isn't an explosion or a bright flash. It's a silent ripple that can stretch the fabric of reality. When they collide, the energy released will dwarf every star in the universe combined. Yet, you might not see any of it with your eyes. So what actually happens when the biggest monsters in the universe merge? That's where things get insane. Because the universe doesn't just destroy things, sometimes it creates something even worse. Black holes don't randomly crash into each other in empty space. It only happens when galaxies collide. Right now, the Milky Way and Andromeda are on a 4 billion-year collision course. Their central black holes are destined to meet. Stars will mostly pass by harmlessly in that event, but the black holes will be pulled straight toward each other like magnets. Once they get close, they become locked in a gravitational death spiral. And the entire time, they release gravitational waves. These waves are ripples in spacetime itself. We have already detected smaller versions of these events with LIGO. Now imagine that same phenomenon, but scaled up to billions of solar masses. The energy becomes almost incomprehensible. As the black holes orbit each other, they spin faster and faster. Each rotation releases gravitational waves stronger than the last. Eventually, their orbit reaches near-light speeds. Space and time begin to stretch around them like rubber. If anything were nearby, it would be torn apart at the atomic level before it even realized what happened. There is no possible way to survive this. Then the final orbit begins. The difference between almost touching and merging is smaller than a single atom. And then everything ends. There is no explosion when they collide. There is just an unimaginable burst of gravitational energy. This energy is greater than every star in the observable universe firing at once. It shakes the fabric of reality. A single gravitational wave from this moment could pass through galaxies like sound through air. It would stretch planets, moons, and even your body just slightly. In a fraction of a second, the two giants merge into one. A new, even more massive black hole is formed. The newly merged black hole doesn't always stay still. Sometimes it gets kicked so hard it flies out of its own galaxy. Imagine a black hole the size of a solar system drifting through intergalactic space like a runaway bullet. That can actually happen. Around the collision zone, gravity reshapes everything. Gas clouds ignite or collapse, stars are torn apart, and new ones are born. Some galaxies recover and rebuild. Some never do. And the gravitational wave from that collision? It's still traveling right now. It's passing through every star, every atom, and through your body as you watch this video. You just can't feel it. People think black holes represent the end of everything. But sometimes, a collision creates something new. The universe is not still or silent. It is constantly rewriting itself through destruction and rebirth. Someday, when the Milky Way collides with Andromeda, our own black hole will face its counterpart. The same story will unfold again, not for us, but for the universe itself. And the ripples will continue long after every star has gone dark. If you want science that feels like cosmic storytelling, welcome to the Nexus Point. Curiosity is how we rewrite the universe.